Hello, boys and girls. Today we're going to be talking about ratios and proportions. This should be familiar to everybody, but we're going to do a quick review day just to make sure that we understand ratios and how they relate to proportions and how we can determine whether two ratios make a proportion. This is really important as we move on to our next unit, which is going to talk about functions. So let's start with an example here. The ratio of boys to girls is 4:3. So you'll notice here that I wrote my ratio in the form of a fraction, but you can write ratios other ways, such like as this or like this, and they all mean the same thing. So I have in words what my ratio is showing, boys to girls, and that is 4/3. Now, the question I'm being asked is, if there are 30 girls in the class, how many boys are there? So I can go ahead and I'm setting up my second ratio here. I also am making sure that my numbers are in alignment with my units over here. So from the beginning, I had 4 boys and 3 girls. And now the problem is stating 30 girls. So I have 30 on the bottom for girls and X on the top for boys. So to determine, since I know that this is a ratio, I know that my numerator and denominator are going to increase by the same amount. So I'm going to go ahead and ask myself, how do I get from 3 to 30? What is the multiplicative inverse, right? How do I get from 3 to 30? Well, I can multiply by 10. So I'm going to do the same thing on the top. I'm going to multiply by 10, and 4 times 10 is 40. So X equals 40, which means if there are 30 girls, there are 40 boys. And I kept my ratio the same because I set up a proportion. How do I know, though, if I have two ratios, that they form a proportion? So one way to tell that is if you can simplify the two numbers or the two fractions or two ratios, and they equal the same thing. So 4/3 is already in simplest form, which is 4/3. 40/30 simplifies to 4/3. And since they equal the same thing, they are considered a proportion. If I have this example, 5/10 equals 6/10, and I want to determine whether these two ratios are proportional, I can go ahead and simplify them to lowest terms and see that 5/10 will simplify to 1/2 and 6/10 will simplify to 3/5. So these are not equal, which means that they are not a proportion. Another way to determine whether you have a proportion is to look at the multiplicative inverse, and we can do that the same way we did earlier. If the top and the bottom, you can multiply or divide, right? Because we can go, oops, that's supposed to be 3. We could go this way and we could divide by 10 and we would get the same thing, since multiplication and division are inverse relationships. Another way you can tell is if you're given a ratio table. So here I have my input and my output. And I want to determine what is the relationship between the input and the output. Think about when you were back in 2nd grade and you talked about the number machines where you would put a number in, something would happen, and then it would shoot it back out. So that's what we want to see here. If I put in 2, I get out 6. What happened to the 2 to give me 6? I multiplied by 3. What happened to the 3 to give me 9? I multiplied by 3. And the 5 to give me 15, I also multiplied by 3. So because I am multiplying by the same number, this is called a multiplicative inverse. My ratios here, 2 to 6, 3 to 9, 5 to 15, they are what we call proportional. And you can also see that if you were to simplify these, they would all be simplified 1 to 3. So we're also checking, we have the multiplicative inverse here, and they simplify to the same numbers. So let's go ahead and look at another example. 6th graders are going on a field trip. There are 5 chaperones for every 75 students. If there are 120 students going on the field trip, how many chaperones? So first I'm going to set up my ratio, which I know I have chaperones to students. And it says 5 chaperones for every 120 students. My second ratio, I have, whoops, that was 75. My second ratio, I have 120 students and I'm solving for the number of chaperones. For this example, I don't see an easy multiplicative relationship here right off the top of my head. So I'm going to go ahead and use another strategy to solve for x, which is cross multiplication. So first I'm going to multiply 5 times 120, and that will give me 600. Then I'm going to multiply x times 75, which gives me 75x. To get the value of x, I need to get it alone, which means I need to undo my division here. I'm going to undo my multiplication by dividing each side by 75. I'm left with x on this side and 8 on this side. So this tells me that when 120 students go on the trip, they are going to need 8 chaperones. So this is an example of how you can use proportions by setting up 2 ratios that are equal to each other and solving for x. Our last example we're going to look at has to do with percentages. And whenever you have a problem with percentages, you can right away create a ratio with the percent, because percent is always out of 100. So this 20% can be written as a ratio of 20 over 100. So back to our word problem here, we have an item costs $75 and is 20% off. What is the discount? So I can tell that this is going to be a part to whole proportion. My first ratio is, I'm going to start with my percentage. So I know that I'm looking for 20%, which is the part of the whole 100. And then my second ratio is the part is going to be my discount. I don't know that. And the whole is $75 because the whole item costs $75. The part is the 20% that I'm taking off. So now, same as before, I'm going to cross multiply. 75 times 20 is going to give me 1,500. And then 100 times x is going to give me 100x. I want to isolate my variable, so I need to undo this multiplication by dividing. This cancels out. I'm left with x on that side, and 1,500 divided by 100 is 15. So my discount is going to be $15. So now on your own, you are going to practice a couple of problems. They're going to be similar to this, where you're determining what the multiplicative relationship is and whether 2 ratios form a proportion. Then you'll move on to solving problems with ratios the way that we did here with cross multiplication, and some problems that involve percents. Make sure to refer back to your notes if there's any confusion.